Hello everyone, good evening. Today I'm going to discuss about the synthesis of Ipratropium bromide. So as you know, Ipratropium bromide can be used in the treatment of COPD. So you know COPD stands for chronic obstructive pulmonary disease. Okay. Apart from that, Ipratropium bromide can be also used in the treatment of asthma. So coming to the synthesis of Ipratropium bromide, right. So the starting material used for the synthesis of Ipratropium bromide is from tropine. Okay, so tropine can react with tropic acid. So if you look at here, when you compare the electronegativity between oxygen and hydrogen, oxygen is more electronegative. The electrons will be attracted towards oxygen. So normally oxygen has two lone pair of electrons. So when you break the bond between oxygen and hydrogen, the electrons present in the sigma bond will migrate towards oxygen to get extra one lone pair of electron. So this hydrogen atom will get positive charge. In the same way, as per the general principles of organic chemistry, this OH group is a very good leaving group. It can leave the reaction very easily by breaking the bond due to the electronegativity difference between carbon and this oxygen. So therefore, this OH will get negative charge and carbon will get a positive charge. Okay, so now what happens? This positively charged hydrogen combines with negatively charged OH minus to liberate water molecule. So when tropine reacts with tropic acid, it will undergo dehydration reaction to liberate one water molecule. Okay, so when OH leaves the reaction, what happens to this carbon here? Carbon has got positive charge. So this positively charged carbon can be stabilized by the oxygen which have one extra lone pair of electron. So oxygen will donate one extra lone pair of electron to carbon. Therefore, what happens? There will be a new bond formation between oxygen and carbon. So if you look at here, you will get the structure in this way. NCH3. Okay. Oxygen So there is no hydrogen and there is no OH here. So oxygen will form a new bond with carbon like this. CH, aromatic ring, and this is CH2OH. Okay, this structure you can call it as atropine. Okay, so if you want to synthesize ipratropium bromide, first we require to synthesize atropine. From atropine, you can prepare ipratropium bromide by reacting with isopropyl bromide. Okay, now this atropine reacts with isopropyl bromide. Okay, so Br, CH, CH3, CH3. Okay, so what happens here? So in atropine, so this nitrogen will have one lone pair of electron here. Now, you look at the structure of isopropyl bromide. Now, if I break the bond between carbon and bromine, so bromine will leave the reaction with a negative charge. What happens to this carbon? Carbon will get positive charge. And here also you remember one thing. Just like your OH minus, halogens like bromine, chlorine, okay, fluorine, iodine, all these halogens are also good leaving groups. They can break the bond very easily due to the electronegativity differences, and therefore bromine can leave with a negative charge. So when bromine leaves the reaction, what happens to this carbon here? Carbon got electron deficiency. So this electron deficient carbon, you can stabilize by using this nitrogen, which has one lone pair of electron. That means nitrogen will donate one lone pair of electron to this carbon. Therefore, what happens? This nitrogen will form a new bond with the isopropyl group here. Okay, so you can write this structure in this way. So I'll try to erase. Right. So I'm going to write this structure. Okay. Now, when atropine reacts with isopropyl bromide, as I told you, the bond will break between carbon and bromine. As bromine is having high electronegativity, it will leave the reaction with negative charge. At the same time, what happens to this carbon? Carbon will become electron deficient. Okay, so to make this carbon stabilized, nitrogen will donate one lone pair of electron for this carbon. Okay, therefore what happens? This nitrogen will form a new bond with carbon like this. So this is a new bond formation between nitrogen and carbon. So here nitrogen, I have written a positive charge, and this is your isopropyl group, and this is NCH3, the same group I have written here, followed by the side chain OCO, CH, CH2OH, aromatic ring, and this is bromine. So this structure you can call it as Ipratropium bromide. Okay, so this is about the synthesis of ipratropium. So ipratropium bromide can be synthesized from reaction with propine and tropic acid, where it will undergo dehydration reaction with removal of one water molecule to form atropine. So again, atropine reacts with isopropyl bromide to form ipratropium bromide. And majorly, ipratropium bromide can be used in the treatment of COPD, chronic obstructive pulmonary disease, and asthma. Okay, thank you.